Welcome to Giving an Answer, the show dedicated to defending the historic Christian faith. I am your host, H.C. Felder, and today the topic is the relationship between philosophy and science. And to discuss this, I have Professor J.T. Bridges. Let me tell you about J.T. Bridges. He has a bachelor's from Ohio State University, a master's of divinity from Southwestern Baptist Theological Seminary. He has a Master's of Arts in Philosophy from Baylor University, and he is currently finishing up his PhD in Philosophy of Religion at Southern Evangelical Seminary, where he is also currently a professor. And welcome to the show.
Thanks, Earl.
And just to let people know that you are legit, let people know what your dissertation for your PhD is in.
Yeah, the title of my dissertation is an evaluation of the intelligent design science neo-Darwinism debate based on an eclectic epistemology of science rooted in Thomistic realism.
Now, that's a mouthful.
It is.
That's a mouthful, and this is our, we've done another show before on the ID movement as well, so the audience can check that out if they get a chance.
Sure.
So, well, let's get into it. First, before we even talk about the relationship between philosophy and science, let's talk about what is science.
Okay. This is actually a debated question within the philosophy of science, is there something generic about science? So the term science is a generic term, and a lot of philosophers have gone away from thinking that there's one thing that characterizes science in general, and they've gone more toward the phrasing of talking about the natural sciences. So, for example, medical science is completely different from particle physics. Their methodologies, the way they study things, are completely different, but they're both science. And so, so one of the things to be at least cautious of is envisioning that there is one thing that makes science overarchingly the same. Now, having said that, I will say that it seems like that there is something that separates science from non-science. This is a problem of demarcation. Again, this is a problem within the philosophy of science, demarcating what science is from what non-science is, and there's always some overlap. But I would say one of the things that people generally have in mind regarding the nature of science is that it's a community of men and women, highly trained professionals looking into some area of natural phenomena, developing theories and formulas to explain that phenomena based on hypotheses that are testable empirically, and that through a trial and error process they can come they can test how close their hypotheses are toward giving an account of reality. It's something like that.
Okay. Well, and since we've now discovered, or you've defined science, define philosophy.
Well,
in a minute.
In a minute, right. Well, literally, philosophia is the love of wisdom. And so going back to the ancient tradition, philosophy was started by the Greeks, Thales and Miletus, etc. Socrates, Plato, Aristotle, I'll say some more familiar names. And it's just well, there are different traditions in philosophy that think philosophy is different things, but for the most part, I think philosophy is a set of disciplines that look at transcendent realities. The philosophy of science is one of those areas of philosophy that's called a second-order discipline. So you could have the philosophy of law, the philosophy of medicine, and what these second-order disciplines do is they sort of stand behind, as it were, the practicing lawyer or medical doctor or scientist, and they ask more reflective questions. What is the philosophy of biology? What is life? A working biologist doesn't need to ask that question in order to be a successful working biologist. But a philosopher of biology is very much interested in what are the necessary and sufficient conditions for the things that we define as living or non-living.
Right.
So things like that.
And one of the reasons why I wanted to do this show was because I did want to discuss that when scientists do science, that there is philosophy involved. Because a lot of times we are under the impression that science they just deal with hard facts and that's it. There's no philosophy involved. It's just, the facts, ma'am, nothing but the facts.
Yeah.
But there has to be some philosophy that goes on behind, even to how to interpret the data that they read. So that's why I thought this would be a very valuable show. Now, you may have already touched on this, but what do we mean when we say that something is scientific then?
Well, probably the easiest way to define what is scientific are the theories and the conclusions coming from the scientific community. Those are the things that are scientific. So, sort of in a common sense way, the discovery of a new quantum particle, that's scientific. Why? Because scientists do that. This is not a this is a descriptive definition, not a prescriptive one. And so we have a pretty good general idea of who the scientists are, and whatever they do, that's what is scientific in a general sense. Now, as you mentioned, there are some things that scientists do, not in the capacity of a scientist or in the service of science, but in the service of philosophy or metaphysics. Like, we talked about things like the multiverse theory, or, well, I would say much of what motivates evolutionary biology is not science, but it's actually metaphysics or philosophy.
Right. Right.
So,
as a matter of fact, because one of the reasons why I asked this is because the other show that we did on intelligent design, how can then scientists say that that's not scientific? Because we have scientists, Christian scientists, who are doing this type of work.
yeah.
So why is it not classified as being scientific?
Well, I think there are some problems with, intelligent design as a scientific paradigm is extremely young. It's, you could probably date it within maybe the mid 80s if you wanted to go back fairly far, which is what, 25 years, which is fairly young for a scientific paradigm. And so in the earlier days of the scientific paradigm, there was a lot of cultural backlash from these ardent neo-Darwinian scientists who clash with the ID community over the ultimate interpretation of the nature of life, the nature of information, things like that. And so the intelligent design proponents were constantly defending themselves, not just on scientific fronts, but on theological and philosophical and religious fronts. And so because their responses kind of went into all these different areas, it became hard to see which were intelligent design science arguments and which were these sort of extraneous arguments that delved into these other areas, like the philosophical implications of it and things like that. And so I think because of the youth of the paradigm itself, it really got caught up in a lot of things that are not essential to it as a scientific theory, and so that was easy to confuse.
Okay. Okay. I just thought it just popped in my mind. I just thought I'd ask that. Then the next question is, what are some of the principles that make science possible? And this is what I'm getting at here. I'm getting at the fact that sometimes we are told that science is the end-all and be-all of knowledge. However, science itself is based on certain principles and certain assumptions that are not themselves scientifically provable.
Right.
So what are some of those things that make science possible, which aren't themselves scientifically provable?
Right. Well, I mean, if you assume that, let's say we're going to do something with the table here, we're doing a physical analysis of the smallest chemical and physical units in the table, we have to assume certain things. We have to assume that there is a table, that there's something objective out there.
Right.
Right? Well, this has been debated philosophically. So that's an assumption, a philosophical assumption that the scientist is making in order to get their process started. We're assuming that the table is not just knowable, but it's quantifiable. There are quantifiable properties about the table, and that we can develop laws and theories regarding these quantifiable aspects, and that those things are true. Most scientists are realists. They think that there is an objective extramental world, that it's knowable, and that our laws and theories apply to them, not just laws of mathematics, but laws of logic and reasoning. These are all assumptions that cannot be grounded in science. Right. Because science assumes them, so it can't prove them.
Right. Right. And maybe getting a little off target, you're a Thomist, I know, and so am I, which means that we'll explain what a Thomist is.
A Thomist of all different stripes, they follow in the philosophical tradition established by St. Thomas Aquinas in the 13th century, who himself followed a lot of Aristotle's philosophy. So it's sometimes called Aristotelian Thomism.
Right.
Yeah.
So he has something called first principles. And if I remember correctly, first principles are something that can't be proven, but they are assumed.
You do remember correctly.
Okay.
Yeah.
What are some of the first principles?
Well, probably the most obvious one is the law of non-contradiction.
Yeah.
Law of non-contradiction says that something cannot both be and not be at the same time and in the same sense. We can't make a logical deduction whose conclusion is the law of non-contradiction. Why? Because every premise in that syllogism or in that argument would have to assume the law of non-contradiction.
Right.
And so it's a first principle because it is not demonstrable. Once you understand what the claim is, you assent to it. You believe that it's true.
Okay.
Right.
What are the various views of science, and what do they say about our understanding of the world in which we live in? Because, like I said, we're talking about philosophy and science, and even within the philosophy of science, there are different views on how the world actually is.
Yes.
Could you just go over a couple of those?
Sure. Well, first of all, in the philosophy of science, you can take sort of two different tracks in describing what the philosophy of science is. There's a metaphysical track that is usually going to track with the different disciplines, so philosophy of physics, philosophy of chemistry, philosophy of biology, and those tend to get into sort of the details of those disciplines and ask metaphysical or ontological questions about the natures of those objects. That becomes all very attenuated. The other type of the philosophy of science is more epistemological. This is where you get the things like the demarcation problem, the problem of induction, and the realism-anti-realism debate, which is what I'm most interested in the philosophy of science, is the realism-anti-realism debate. This is an epistemological debate, a debate over...
When you say, what do you mean by epistemological debate? What do you mean by the problem of induction? I mean, I understand what you mean, but
sure,
you had to break it down a little bit.
For the unwashed masses.
Right.
Yeah, the problem of induction says that, okay, inductive inferences, as opposed to deductive inferences, which give us necessary conclusions, inductive inferences start from a sample size and lead to probabilistic conclusions. So it's more likely that, or it's more probable that, or it's less probable that X happened based on these instances, okay? Well, the problem of induction says that how is it that you can reach any sort of necessary or sufficient conclusions about things that only have probabilistic reasoning? So, for example, after the early modern skeptic David Hume, he's kind of famous for raising the problem of induction because his epistemology, his theory of knowledge, was that all the events that we see are disconnected. They're not necessarily connected with one another in cause and effect relationships. And so because of that, we can't have access to what is actually going on. All we have is these constantly conjoined scenarios. And so while it's always been the case that the sun has risen in the morning, it might be that the sun doesn't rise tomorrow. And so no matter how many trials you have, you can't be certain that the next trial is going to give you the same sort of response. So this is the problem of induction. And so because science is inductive in its nature, philosophers of science have sort of taken on the burden of debating the nature of that problem.
I've actually had a discussion with an atheist on the problem of induction. I was trying to explain to him the problem of induction.
Okay.
And the example I used was, it was thought that all swans were white.
Yes.
Until we found black swans.
Yeah.
Now the problem of induction is that, well, all I've ever seen is white swans, but I don't know what percentage of swans I've seen.
That's right.
Because I may have only seen a very minute portion of swans in the world.
Right.
And I'm basing my whole understanding on that.
Yes.
And we never knew how many swans there were, so it seemed logical, but it was wrong.
Yes.
And another example is that the Aborigines thought that all people were black. Right. Until they saw white people, because why would they think that there was any such a thing as white people? Because every person they've seen is black. And it's and this is the problem you're saying of induction, is that science is based on observation, but when we look at something, we don't know what the sample size truly is. Right. All we know is that we've seen this, we've seen that, we've seen that, and in all of those cases, X, Y, and Z followed. Right. But that doesn't necessarily mean that that is always the case.
Right. Yeah, and going back to Thomism for a minute, which everybody was anxious to do, I'm sure. I think the way out of the problem of induction is like the black swans or the pigmentation of our skin. These are accidental qualities of the objects involved. So whether a swan...
When you say accidental...
Sorry. They're not essential. They don't make the thing to be what it is. So your black skin, my white skin, they don't make us to be human. Our humanity is something essential to us. Our skin pigmentation is something accidental. I could go to the beach this weekend. I'm going to the beach next weekend. If I come back with a tan, I'm still essentially the same, even though I'm accidentally different. So the problem of induction really gets off the ground when you give examples that touch on things that are accidental to an object and not essential to an object. So for example, Aristotle defined humans as rational animals. That is, if you find an irrational animal, you can know that it's not human. If you find a rational animal, you can know that it's human, because this is essentially what humans are. Now, this is only possible if you are a realist in your epistemology, in your theory of knowledge.
Explain what a realist is.
A realist is somebody who believes that that particular objects have essences, they have natures, they have something ontological or metaphysical about them that make them to be what they are, and that our mind has access to those objectively. So there's oftentimes a confusion between the problem of induction as it's stated, as it follows from early modernity and David Hume, as it's taken up by contemporary philosophers, because they only look at induction as a logical sequence. So if all the premises are probable, then the conclusion can only be probable. This is a way of looking at inductive inferences. But Peter Kraft, who's a Thomistic philosopher and wrote the book Socratic Logic, Peter Kraft explains that induction is not simply a category of inferences, but it's also a metaphysical act of the mind. So in Aristotelian Thomism, by looking at 1,000 different cups, I can come to know what it is that makes a cup a cup. So that when I see a cup that is not black and white, perhaps it's red and brown, I know it is a cup.
Right.
Why? Because I'm able to understand conceptually what it is that makes this thing essentially what it is to be a cup or a human or a dog or a tree. So then when I come into another instance of that kind, I'm able to say, well, here we are, here's another tree, here's another table, here's another human being.
Okay.
Right.
So we have the different views. We have this, scientific realism.
Yes.
Right? And we have scientific anti-realism.
Yes.
And anti-realism.
Yeah. Anti-realism and should not be confused with something like wholesale skepticism. So David Hume is a wholesale skeptic. He doesn't think that we can really know with any robust certainty things going on in the world, right? Well, in the philosophy of science, the realism-anti-realism debate is not global in nature. It's not general in nature. It's very specific. And the realism-anti-realism debate is really over the nature of scientific theories. So scientific theory says we see phenomena X, Y, Z, so we posit this entity that exists. So part of our theory includes that this entity exists that explains this phenomena, right? So the realist tends to say, well, the aim of scientific theories is to give us a literally true story about the world, and that when we posit theoretical entities, we're saying something true. We're saying something about a real entity. So for example, neutrinos. Neutrinos are very small. They hardly ever interact with matter, but John Losey, in his historical introduction to philosophy of science, says that there are certain experiments where if you get these precise mathematical interactions between these other particles, you can know that a neutrino passed through your cadmium ion solution or something like that. So we don't see the neutrino itself, but what we do see is all this specific mathematical effects of what a neutrino causes. So the unobservable object, the neutrino, the realist says, yes, we can be pretty certain that the neutrino exists. The anti-realist says, no, 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 we don't have any sort of empirical confirmation for that, so the theoretical entity is just part of the theory, it's not necessarily true. So between philosophers of science who are realist and anti-realist, they're talking about the status of scientific theories and then the theoretical entities that those theories posit. Are they true? Do they say something about the real world? Or are they just scaffolding that gives structure to some of the data that we have, which you alluded to earlier.
Right. Okay. So what are some of the problems with science, and what are some of the limitations of science?
Well, remember we started talking about the table. And if we're going to approach the table, scientifically, we have to measure it in some way. So the object has to be measurable. It has to be empirical in nature, right? On an earlier show, we talked about how the multiverse really isn't a scientific concept. Why? Because it's not positing something that's empirical in nature. It's not something detectable by empirical means. So that's something that science has to do. What follows from that is that if there are aspects of reality that are not empirical in nature, they are not scientifically detectable. So if God exists,
Right.
we can't talk about God in his nature as a conclusion from a scientific argument. Now, science can point to some of the effects in nature that we think God is the best explanation for.
Right.
But theology itself is something that philosophers and theologians talk about, because they're talking about a spiritual, infinite being, right, who's immaterial in nature. If angels exist, if the human soul exists, these are not things that are measurable, quantifiable, and so they're not. They are aspects of reality, but they're not scientific in nature.
Now, so how do you respond to someone who says, and a lot of scientists will say this, is that if you can't prove it scientifically, then you shouldn't believe it?
Yeah, this is it's actually a philosophical position called scientism that says that the only way to get at the truth about reality is through the scientific method, right? So the sciences are the only way in which we get at the truth, objective truth. Everything else is sort of opinion, it's intuition, it's maybe emotion, but it's not science. It's not really knowable. The problem with scientism is that it's a philosophical position, right?
Right.
So the objection to scientism is this. If philosophy can give us truths about reality, then scientism is false, because it says the only way to know anything about reality is through science. If philosophy can't give us any truth about reality, then scientism is false, because it's a philosophical statement. So either we can know philosophically something about reality, or we can't, right? This is the law of excluded middle. Either way, scientism is false.
Yeah, and it's also like a self-defeating statement.
Absolutely.
The thought that science is the arbiter of all truth can't be proven scientifically.
That's right.
You can't prove scientifically that science is the arbiter of all truth.
Science is the only way to know truth, said the philosopher.
Right. And that's another thing, another reason why I wanted to do this show, because I wanted to expose some of the things that are being passed for science that are really philosophy.
Yes.
Because we see this happening when we look at things like evolution, when we look at intelligent design. We see scientists saying one thing, but it's not based on science, it's based on philosophy, which is why I think this show is so important.
Yeah. Well, I think Frank Turk wrote an article entitled, Science Doesn't Say Anything, Scientists Do.
We did a show with that exact title.
Okay, there you go.
We did a show with that exact title.
So he makes that point. The scientists are humans, and as humans, they're metaphysical creatures, right?
Right.
So, and because they're not trained in philosophy, scientists make very poor philosophers oftentimes, even really smart ones like Stephen Hawking.
Right.
Right?
Right.
So because they're not trained in areas of philosophy, they will stray into areas of epistemology and metaphysics without knowing it and thinking that they're just continuing to do their science, which they're not.
An example is the multiverse.
Yep.
The whole multiverse thing is a perfect example.
Yep.
Now, this is something that's come up in the news very recently, and I knew I was going to have you on the show, so I thought I'd ask you about this.
Okay.
What is the God particle, and are there any implications for Christianity?
Well, fortunately, because professors, we have other experts that we listen to. So even though we're sort of at the top of the food chain academically, we have other experts in other areas. And one of the philosophers that I really enjoy is William Lane Craig. I listened to a podcast that he gave just recently on the God particle. And what the God particle is the Higgs boson. So in the standard model of quantum mechanics looks at the quanta, the individual packets of energy represented by the four fundamental forces. Actually, they're still looking for the one that represents gravity. And then all the different particles that, you know, the quarks that go into building the protons, the electrons, and how they interact with each other. The different, well, the Higgs boson, as I'm made to understand it, is the last piece of the standard model of quantum mechanics. So the last piece of the standard model that to be empirically verified, right? And so apparently what the Higgs boson is that it's a quanta particle of the Higgs field. So you've heard of electromagnetic fields,
Right.
The quanta particle of that is the photon, right? So there's the field, the energy, the force, and then it's quantum particle. Well, the Higgs field has been postulated as part of the standard model for a long time, since I believe the 70s. And now what's happened is they've just obtained empirical evidence that the Higgs boson exists. And so the question on the table is, what are the implications for Christianity? And the short answer is not a lot. The reason is that the Higgs boson has been part of the theoretical framework of quantum mechanics that's been around for decades. So this discovery, as marvelous as it might be, is not revolutionary in terms of scientific. There hasn't been a scientific revolution because the discovery of the Higgs boson. Right. What has happened is one part of a theoretical framework that was already accepted has become empirically verified. So while it's a great scientific discovery, it's an empirical verification, it's not revolutionary. And so I think some of the celebrating over the Higgs is somewhat hyperbolic. You know, it's just, it's not like the Einsteinian revolution from Newtonian physics. I mean, it's important, but it's not revolutionary.
Okay, Professor J.T. Bridges, that will bring us to the end of the show. I appreciate you coming on and talking with me about the relationship between philosophy and science. And that will end this. Be sure to join me again next time. And until then, goodbye and God bless.
You can find out more about Giving an Answer, as well as listen to other episodes by visiting us online at www.givingananswer.org.
For the 19 years.